Hello everyone. In this lesson we will going to study about elimination reaction. In the previous class you have studied about nucleophilic substitution reaction. The mechanism of elimination reaction is somehow similar with the mechanism of nucleophilic substitution reaction. But there is a slight difference between these two. Let's discuss about it. In content we will cover introduction, types of elimination reaction, that is unimolecular elimination, E1 reaction, and bimolecular elimination, E2 reaction, along with its mechanism. Then Zaitsev elimination reaction and Hofmann elimination reaction. Introduction. What is elimination reaction? An elimination reaction is a type of organic reaction, in which two substituents are removed from a molecule, by the action of acids, bases, metals, or high temperature, either in one or two-step mechanism to give an alkene. That means it involves the removal of two substituent from the substrate molecule. See the diagram. Here the two substituent are hydrogen and halogen, that is X, which is a leaving group. To carry out a elimination reaction, substrate should always be a alkyl halide. The product of elimination reaction is alkene. So it is the process by which saturated compounds are transformed to unsaturated compounds. If elimination take place from adjacent carbon atom, for example base removes a proton from the beta carbon atom, while the halogen atom leaves from the alpha carbon, during which the double bond is formed between carbon atoms. Such type of eliminations is called beta elimination reaction or 1,2 elimination reaction. In a elimination, leaving group may be halogen, hydroxyl group, OR, N2+, N3, H2O or Nr3+. If both hydrogen and halogen are removed, then it is known as dehydrohalogenation reaction. The difference between substitution reaction and elimination reaction is that in substitution reaction, the electronegative atom is replaced by another electronegative atom, whereas in elimination reaction, the electronegative atom is eliminated along with the hydrogen from the adjacent carbon atom. It is shown in diagram that X is the leaving group and Y- is the base. If the reaction undergoes substitution reaction, then base Y- will replace the leaving group X- to give the substituted product. But if it undergo elimination reaction, then base Y- will abstract the proton with the elimination of leaving group X-, to give unsaturated product. There are two types of elimination reaction. One is unimolecular elimination reaction, E1 reaction. And second is bimolecular elimination reaction, E2 reaction. We'll study each type of elimination reaction along with its mechanism. E1 reaction. E1 stands for unimolecular elimination reaction. Usually tertiary alkyl halide favors E1 reaction. See the example when tertiary butyl bromide, which is a tertiary alkyl halide on heating with alcoholic potassium hydroxide, undergo elimination reaction to form alkene, that is 2-methylpropene. Now we will see the mechanism of E1 reaction. The mechanism of E1 reaction is similar with the mechanism of SN1 reaction, which involves a carbocation intermediate. E1 reaction proceed via two steps mechanism. Step 1 involves the heterolysis of CX bond, forming an intermediate carbocation. That means the bond to the leaving group, that is CBr bond, breaks first, before the pi bond is formed. In this reaction, tertiary butyl bromide dissociate to form tertiary butyl carbocation. In step 2, the base OH- remove a proton from a carbon adjacent to the carbocation, that is from beta carbon. And the electron pair in CH bond is used to form the new pi bond. In this reaction, base abstract a proton from beta carbon of tertiary carbocation to form 2-methylpropene, which is a alkene. Out of these two step 1 is the slow step and rate determining step, which involves only tertiary butyl bromide. Therefore, rate of reaction only depends on the concentration of tertiary alkyl halide. Hence it is a first-order reaction. E2 reaction. E2 stands for bimolecular elimination reaction. Here primary alkyl halide usually favors E2 reaction. Consider the dehydrogenation of bromoethane. In this reaction, bromoethane react with alcoholic potassium hydroxide, undergo bimolecular elimination reaction, to give ethene as elimination product, along with the byproduct that is potassium bromide and water. This is the direct reaction of bimolecular elimination. Hydroxide cannot act as a nucleophile in this reaction because of the bulky tertiary halide. Rather, hydroxide act as a base and abstract a proton from beta carbon. Now we'll see the mechanism of E2 reaction. The mechanism of E2 reaction is similar with the mechanism of SN2 reaction, which involves a transition state. Mechanism of E2 reaction involves one step. In this reaction, the base OH- remove a proton from beta carbon, forming H2O as a byproduct. Then the electron pair in beta CH bond forms the new pi bond. The leaving group Cl- comes off with the electron pair in the CCl bond. That means two group departs simultaneously, with the proton being pulled off by a base. And in transition state, the breaking of CCl bond and CH bond take place simultaneously. Transition state in E2 reaction is most unstable state, because carbon is having 5 bond. Now let's discuss its reaction kinetic. Though mechanism of E2 reaction involves one step, so rate of reaction depends on the concentration of both primary alkyl halide and nucleophile. Hence it is a second-order reaction. Zaitsev elimination reaction. Zaitsev elimination reaction follow bimolecular elimination reaction, where abstraction of hydrogen and halogen take place simultaneously. If you are taking alkyl halide having 2 or more different beta carbon, as you know, proton abstracted from beta carbon. Therefore more than one alkene product will formed. Out of these two, which is the major product and minor product, it can be predicted by a rule, known as Zaitsev rule. Now we'll discuss what is that rule. According to Zaitsev rule, when an alkyl halide subjected to elimination reaction, highly substituted alkene is, as a major product, and less substituted alkene is the minor product. That means major product is obtained when a proton is removed from beta carbon, which is bonded to less hydrogens. And major product is the most stable product. It can be easily understood by this reaction. See, here 2-bromobutane, which is a alkyl halide having 2 beta carbon, when react with alcoholic potassium hydroxide, it gives 2 product. One is but 2ene and other one is but 1ene. If you observe the first product, that is but 2ene, it contain two substituents means 2CH3 group. Whereas but 1ene contain one substituent 1CH3 group. So according to Zaitsev rule, high substituted alkene is the major product. In this reaction, but 2ene is the major product having more substitution. Hofmann elimination reaction. Like Zaitsev elimination reaction, this reaction also follow E2 reaction, where abstraction of hydrogen and halogen take place simultaneously. The Hofmann elimination reaction is used to convert an amine with a beta hydrogen to an alkene, using methyl iodide, silver oxide, and water under thermal conditions. For example, when trimethylethyl ammonium hydroxide, which is a amine, react with base OH-, then the base subtract a proton from beta carbon, along with the removal of tertiary amine, to give an unsaturated product that is ethene. But if you are taking a amine substrate having two or more beta carbon, then more than one alkene product will formed. Base may abstract proton from either of the beta carbon, to give two different product. Out of these two product, major product is decided by a rule, known as Hofmann rule. According to Hofmann rule, steric effects have the greatest influence on the product of Hofmann elimination reaction. So, the loss of the beta hydrogen occurs preferably from the most unhindered, that is least substituted, carbon atom. The unsaturated product, alkene, with fewer substituents, will be the major product. Hofmann orientation is caused because the acidity of beta hydrogen is decreased by the presence of electron-donating alkyl group. In this reaction, tertiary amine undergo elimination reaction to give two product. One is prop 2ene with 6% yield and another is prop 1ene with 94% yield. So, prop 1ene is the major product. If you compare these two product, as it is less substituted, means contain one CH3 group, it is the major product according to Hofmann rule. Remember that Hofmann rule is the reverse of Zaitsev rule. Thank you.